pine cone falls from a height of 5.6 meters. It strikes the ground at 8.21 meters per second. What was the average force of air friction slowing the pine cone as it fell? The famous pine cone problem, okay? So here's our pine cone. Is that a good pine cone? Kind of looks like a turd. All right, and it falls, let's see, 5.6 meters, right? So I'm going to assume that its initial velocity is 0, okay? Unless it's like a windy day, you know, right? And when it gets to the bottom here, our pine cone is now going 8.10 meters per second, okay? But then it says, what's the average force of air friction slowing the pine cone as it falls, right? So again, the things we can know force times distance and mgh and 1/2 mv squared, okay? On the left side of the equation is this, where it's right here, okay? I'm going to argue that it only has potential. There's no force speeding it up. It's not moving. It's only mgh, okay? Now, where does that energy go? Well, it's moving at the bottom, so it has kinetic energy, right? It definitely has this, okay? But at the very bottom, it doesn't have potential. But I think there's a force that acts to slow it down on the way down, and that's that force of air friction, right? So I'm going to say that this equals force times distance plus 1/2 mv squared. So now let's make a number sentence here, right? The kinetic energy turns into work against the air friction, right? A force that slows us down, plus kinetic energy. And now we're set, okay? So the mass is 0.113 times 9.8 times 5.6. That's our potential energy, right? And then some unknown force, and that unknown force acts over that whole distance, right? Now, to be sure, the reason it says average force of air friction is that the force of air friction gets bigger and bigger the faster it goes. Calculating that acceleration instantaneously is, beyond the scope of our course, let's just say. Okay, 1/2 0.113, whoops, times, it's going 8.1, right? Okay, so the force is what we're solving for. So let's figure out this term, 0.113 times 9.8 times 5.6. This is 6.20144. Is force times 5.6 plus. And then let's figure out this thing. So 0.5 times 0.113 times 8.1 squared. That's 3.706965. Okay, now if you see, like, this is how much energy it has, this is how much kinetic energy it's got. The difference between this and this is how much energy is lost. So I'm going to go this guy minus this guy. So 6 point whatever minus this 3.7 guy, and that is 2.494475. That is force times 5.6. So if I divide both sides by 5.6, I'll get what the force is. So the force is 0.445 newtons. It keeps going. There's a lot more digits there. Okay? All right.